Hello and welcome to SudoKanard. We're here to solve this sum 5 to 15 Sudoku puzzle, which was created by Diana Škrhová from Slovakia for the round 3 of WPF Sudoku Grand Prix in 2024. At the time I'm making this video, this was a month ago, and I didn't try the puzzle during the contest. I solved it afterwards, and it was really a difficult puzzle, as the 114 points suggest. And that might have been undervalued even then. So what is the point of this puzzle? Well, it's a kind of killer Sudoku, and by this I mean that here the sum of those digits is 6, here the sum is 15, here the sum is 8, etc. But sometimes the sums are not given. So how do you decide about this? Well, every sum from 5 to 15 must appear exactly twice. And in both instances, the decomposition must be different. So for example, with 6, one of them will be 1 plus 5, and the other one will be 4 plus 2. And this can be disambiguated from the start in this case. In this case, we know that this is 1 and 5, and this is 2 and 4. So we must find the other sums, even when we don't know what the total is. So this is pretty difficult, and I haven't solved it since the moment I solved it after the contest 1 month ago. So let's try to do this. So what I'm saying first is that it took me quite some time to see that when I solved it, is that in those 5 rows, this digit here, or this cell, is not in the cages. And that's very interesting, because we know exactly what digits we have in those 5 rows. We have 5 times the digits from 1 to 9. It's a well-known secret in the community that the sum of all digits from 1 to 9 is 45, and 5 times 45 is 225. But the sum of numbers from 5 to 15 is 110. Well, I let you do the calculation, and we know that in those 5 rows, except for this digit, we have 2 times all sums from 5 to 15, which makes a total of 220. So 225 minus 220, that tells us that this is a 5. Which is nice, but not so great. It doesn't give us that much. Perhaps it's interesting to do some Sudoku logic. For example, those 2's say that there is a 2 here. 2 won't work in the 12 sum, so that is a 2. There's a 2 somewhere here, and there will be a 2 somewhere there. Oh, by the way, I should use some pencil marking, some coloring. Here I drew a chart or a table with all sums from 5 to 15, and I will use blue to say this has been found once, and green this has been found twice, and by found I mean resolved. So 6 has been resolved 2 times, and I think this will do the trick. So what is next? Well, just by the rules of Sudoku, we have a 1 here. 4 will appear somewhere here. Those are from 3, 7, and 8. No, sorry, 3, 7, and 9. 2, 3, 7, 8, that's not interesting. What about this? We know that this is not 2a, this is not 4 6, so this has to be with odd digits, this 10. This 7 doesn't use the 6, so it's either 2, 5 or 3, 4, and knowing this, that will be the odd digit and that will be the even digit. And those 5s tell us that this is not 5, 8. Actually, there is a 5 somewhere in here. So this is not 5, 8. It can still be 4 and 9 or 6, 7. This 8 here doesn't use the 6 nor the 5, so this must be 1, 7. So there will be another 8 cage somewhere, and it won't be 1 plus 7. I will say that this 7 is half done. Now this 12 here doesn't use the 4. It could be 5, 7 in this order. Oops. Or 3 9s one way or another. This is from 3, 7, and 9, by the way. Actually, looking at those 7s, this has to be a 7, just by Sudoku. And this also has to be a 7, so this is not 7, and this is not 6. Here we have, down there, 2, 3, 8, and this is 9. So that this is actually 3 and 7. This is not 3, this is not 9. So no 9 here. This is 3, 7. This is 4 and 9. And this is 2 and 3. And this is 5 and 8. 10 is half done now. Four will appear somewhere in here. This column needs 1, 5, 4, 8. So this is from 1, 5, and 8. This can't be 1 or 5. So this is from 4 and 8. What else do we have? So this column still needs 2, 3, 4, 8, 9. So this is from 3, 8, 9. We have some measure of limitations on this 15 because of those digits. 15 can be 6 plus 9 or 7 plus 8. And an interesting point is, sorry, I was already thinking about something else. What was I saying? The interesting point is that both possibilities for 15 will have to be located somewhere in the grid. So this column still needs 3, 5, 6, 6 on this column must be here. And this is 3, 5, and 9. So that's interesting. This can be either 9, 11, or 15. So if this is a 9, then this must be 7 and 8. That's a little too early to decide on that. Those are from 3, 5, 8, and 9. There's a 5 here, so this is from 3, 8, 9. And 5 can only be here, regarding this. So this is from 3, 8, 9. So this is kind of interesting. This is either 8, 13, or 14. Well, when you solve it on paper, you can write down the possible sums, which is very useful. And that's what I did when I solved it on paper. So we'll see if I manage to put it off without this. This column still needs 2, 3, 4, 2, 3, 4, 8, 9. This is not helpful. So how am I doing this? So at some point I will have to decide what is happening. I must have a 6 somewhere here. This is really, really hard. At this point, I really don't know where to look. Perhaps I should have prepared this video. Well, I didn't. So I was saying 9, 11, or 15. Is there anything? Because 15 would be very powerful. 6, 9, 8, 7. It would put an 8 here. That's interesting. That's kind of interesting. Or perhaps I should locate the 5s. Yes, you can say that the sum 5 has to appear twice in the grid, once as 1 plus 4 and once as 2 plus 3. And perhaps it would be a good idea to locate them because there can't be that many places where they appear. For example, let's use some coloring to just rule possibilities out of it. So I'm using coloring to say this can't be 5, this can't be a sum of 5. And here 2 and 4 are unavailable, so this can't be a sum of 5. This could be 4, 1, this could be 4, 1. No, 1 is not available. This has a 2, it could be 2 and 3. This could very well be 2 and 3. Those would never be 2, 3, or 4, 1. This could be 2 and 3. This could be 3 here and 2 there. Oh, no, it couldn't, because there's a 2 here, there's a 2 here, there's a 2 here, so this could never be a 2. So this is actually blue. So here we have a 2 or a 3, so this will never be 2 and 3. And it can't contain a 1 either. This could never be 2 and 3 because we would have no candidate for this. So very, very few options for the 5 cages, but this can't be 1, 2, 3, 4, so this is not a candidate either. This couldn't be 1 and 4, but it could be 2 and 3, I think. This could work. This couldn't be 2 and 4. It could be, no, 2 and 3. It could be 1 and 4, I think. I think this would work. I don't see any issue with 2, 3 being here. And now the question is more about where is 1 and 4? 1 and 4 is not here. 1 and 4 is not here. 1 and 4 seems to work there. There are quite a number of options, actually. This also seems to work. That was a valid quest, but it doesn't seem to resolve at this point. So I will leave this coloring on. perhaps I should be looking for 15, but there, let's say I use this, so 15 here would be an option. 15 here would be an option. 8 or 9 with 6 or 7, and the other possibility here with the 3 there and a sum of 8 different from that. This is truly confusing. Could this be 7 and 8? 4, 9, 5, 2, 3, 1 here. That seems to work. Now that's really confusing. I'm just thinking about those cells actually. There's something with 3, 4, and 7. Oh yes, I'm remembering this. That's Sudoku. 3 and 4 here wouldn't work because I would have 7 in both cells here. So this has to be 5 and 2. That's interesting. This is 3, this is 2, this is not 3, and this here is a 3. Oh, that's much more interesting. And this 8-9 pair turns this into a 4. And I can place a 1 in here. And this is 4-8, which means we have located the second 12. And we have fully resolved this 7. We have resolved this 8. Unless it was already done, I just don't remember. So something has been happening here. That's interesting. All 12 have been resolved. I'm just noticing now this 3-7 pair. I guess it will play a part at some point. So here we have 9 or 15. Here we have 13 or 15. And if it's 13, then it's different from that anyway. And I'm noticing here there's an 8-9 pair in those cells. Whatever digit is here is not there, but the other 8 or 9 is in here. So we have located 8, 9, and those digits. The rest are from 2, 4, 6, and 7. And I will pencil mark that. 4 is not here, so this is from 2, 6, and 7. This is not a 2, so this is from 4, 6, and 7. So this is either 7, 9, or 10. Oh, but there's a 10 here with 3 and 7, so this can't be a 7 after all. So I would just note, oh, I've already noted that 10 has been half resolved. An interesting point is that those can't both be 3 and 6, meaning that if this is 6, then this is 9. Oh, wait. What was I saying? If this is 6, then this has to be 7, 8. And if this is 6, then this can't be 6, 3. Sorry. So this has to be a 9. And this also has to be a 9, and this is 8, and this is leading me nowhere, I'm afraid. And if this is 4, and this is 2, this is 4, and this is 4, and I can't do anything with that. I'm afraid. Oh, so I'm just noted. So here is a 3/7 pair. So this is never 2 and 3. So this is no more a 2/3 cage. So the cages with the sum of 5 are in this ring, on this ring. There's a 2 in here. I could still have 2 and 3 here, I think. With 1 and 4 there. 1 and 4 is never here. 1 and 4 is never there. So 1 and 4 is somewhere in here. Oh yes, that's very interesting. So I think I have located that the 1/4 cage that makes up the 5 is either here or there, and in both cases this will never be a 4. So that's a 6, this is 8/7, this is 9, this is 2, I said, this is 4, and this is 2. So now this is 3 and 6, this can't be 3 and 6, that is 6 and 9. This 9 turns this into a 5, which is accompanied with a 7. This is 1 and 7. And this is 8, and this now here is a 4. So a flurry of activity. This is 3 or 9. So let's ponder. We have located all 15 cages. We have a 9 cage here, another 9 cage here. So 9 is fully resolved. We have a 12, they have both 12 cages, yes, we have both of them. So what comes next? Those here are from 2, 3, and 9. There's a 9 here, so this is from 2 and 3. The plot thickens. This is from 2, 3, and 9. This 5 and this 7, this ambiguates some stuff down there. Here I need a 6 and a 9. So here the sum is either 8 or 11. This 5 here, that's the 1, that's the 5. I need an 8 somewhere in here. 5 is not, actually 1 can only be here in the column, and that is 8. Those are from 6, 9, and 8, so 6 or 8. 6, 8, 9. There's an 8 in here, but 17 is not allowed as a sum, so it will be 14. That's the 9, that's the 6. This is 6 and 7 after all. So that's 8 and 6, that's 3, that's 7. This is 4, this is 8, and this is 1. So here we have 10 and 10. 10 is done. Here 8, we already had the other 8. So 8 is done. 13, we have a 13 done already. So it can be 13, it can be 7. We still need one of each. And this can't be 17, so this will have the 3. And this has the 9. Oh, and this can't be 2 and 3 anymore. 2, 3, 4. Oh, well, let's ponder what I just said. That's 11. Right, that's 14. We still, so here we have, what do we have? I've been missing something, I'm afraid. Here we have the 2 5s. We have both 13s. Do we have both 14s. We still need 9 and 5 somewhere. Yes, we have 1, 9 and 5 here. So here we have 5, we have 2 5 cages, and 11 and 7. And the 1 and 4 can only be here at this point, because at this one, so the 1 and 4 has to be here. This is 1, this is 4. So this is 9. We still need 11, so that's the 2, that's the 3. Here we need 2, 3, and 4, so that's the 3, that's the 2, that's the 4, and here we have the 7 cage and the 5 cage. So this part is done. Now we just need to finish the Sudoku part, which will be basically instantaneous. 9 here, that's 3, and that's 2. And that's it. So it's an impressive puzzle, in an impressive construction. How Diana came up with such an idea is just incredible. This is the kind of stuff you usually see on Cracking the Cryptic. And perhaps it was covered on Cracking the Cryptic. I don't know. I didn't pay attention. Perhaps I should. But anyway, this was quite the adventure. And the video is not that long, actually. Perhaps the 114 points were worth it after all. Thanks for watching this video. See you soon on SudoKanard.